Hello, welcome back. In this video, we are going to learn about transmission impairments. Let's look at the agenda. We will be learning about the transmission impairment factors. We would be touching the signal deterioration part and then the noise part. Whenever a signal passes through a transmission medium, it can be hit by noise. And due to this factor, there can be changes in the signal that is getting transmitted. We are transmitting XT at the sending end and it passes through the channel where the channel is the part where the signal is weakest and it may be hit by noise. Let's say it is hit by the noise ZT. And at the receiving end, if we receive YT will not be exact replica of XT, but YT will be given as XT plus ZT. So this is called the additive noise, where the noise is getting added to the signal. So due to this, transmission impairment occurs. Now let us see what are the different factors that are responsible for transmission impairment. Number one is the signal deterioration. Signal may be deteriorated majorly the signal may be deteriorated in the form of its amplitude. Or form. Or intensity. So we can have attenuation of the signal where loss of energy occurs, and we can also have distortion of the signal where the entire signal shape may be changed. The next impairment factor is the noise. Noise is a very important factor because when a signal is hit by noise, the signal may be totally changed. For example, if we are dealing with binary signal, due to noise, if it is transmitting 101101 due to noise, this is at the sending end. At the receiving end, this signal may be erroneous and we may get 111001. So we can see that there is error in this position and also error in this position. So due to noise, specifically the binary signal may be entirely changed and the meaning of the signal will be changed. So these are the various impairment factors. Let us understand signal deterioration in detail. What is attenuation? It is the loss of energy of the signal. Let's say we have transmitted this sine wave at the sending end. So this is the transmitted signal at the transmitting end. Due to loss of energy or this is a form of signal deterioration, the receiving signal may be attenuated and we may get it like this. So here the shape of the signal and the phase of the signal, the frequency of the signal remains the same, but it is attenuated in nature. We can see the amplitude is diminished. Amplitude of the signal decreases. So here along y-axis we are plotting the amplitude. So we can see here the amplitude of the signal has got diminished. So this is known as attenuation, and this attenuation is measured in decibels. It is given as log base 10 P2 by P1, where P2 is the power of the signal at the output of the transmitter, and P1 is the power of signal at the input of the transmission medium. Basically, this is the transmission medium. So P2 is the power of the signal at the output of the transmission medium. So this is about attenuation. Next is distortion. Distortion means the shape, form of the signal or the phase or the frequency of the signal may be changed as it passes from one point of the network to the other point through the transmission medium. For example, if this is the signal that we are transmitting, the received signal may be a completely changed signal. For example, it can be like this. We can see the shape of the signal has also changed. The frequency has changed. The phase has changed. So the signal is totally distorted in nature. This mainly happens because a signal may be a composite signal and it has different components which may arrive from the transmitting end to the receiving end via different paths. So this may be one path, path 1, this may be path 2, this may be path 3. So as they are taking different paths, having different delay components, so delays are also different for different paths. So the signal that is received at the receiving end, all the signal components may have different phases and frequencies due to this delay. And when these signals are received at the receiving end, total distortion of the signal may happen. Like this may be the output signal, and whatever signal you have transmitted may be this type of signal. So this is called the distortion. Next, let us understand the different types of noise that are in existence. We can have thermal or Johnson noise. Mainly this happens due to the thermal agitation of electrons in a conductor. So this is the thermal noise or Johnson noise. Next, we can have short noise. Mainly short noise occurs when there is a potential difference in any PN junction device. For example, PN junction diode and transistor consists of this potential difference. We also call it the potential barrier. And when the holes and the electrons try to pass through this barrier, the short noise occurs. Next is the 1/f noise. It's also called the flicker noise or the pink noise. It happens in nuclear plant. After that, we have white noise. White noise is a noise which has a constant power spectrum over the frequency range of occurrence. So this white noise, the example of white noise is the thermal noise or Johnson noise. Next, we have additive noise. We have learned about additive noise when the noise gets added to the signal, and in this case the random term of the signal is not dependent on signal state. We can have multiplicative noise when the noise gets multiplied to the signal. In this case, the random term of the signal is dependent on the state of the signal. Here we come to the end of this video. In this video, we have learned about the transmission impairment factors. We have seen signal deterioration. We have seen what attenuation is all about. We have touched upon distortion. We have seen various types of noises that can cause signal deterioration. Thank you.